Okay, good afternoon, good morning, students. Today you just have to watch this video, take the notes and follow the notes, and then at the end when you're completing the notes, you submit them, okay? Today is December 4th. And today we're going to start with lesson 3.3. And this one is called Prove Lines Are Parallel. Okay, so this is our title. We just finished lesson 3.2. In this lesson, we're going to use the algebra to prove the lines are parallel. So this is what we're going to learn today. Write it down. Today we will learn to use angle relationships to prove that lines are parallel. Okay? And we're going to begin with postulate 16. Postulate 16. This one is called the corresponding angles converse. Why is it a converse? Because it's we switch the subject and the conclusion of the other postulate, and now we make it our conclusion on the other one is now the object of our postulate. And it says, if two lines are cut by a transversal, so that the corresponding angles are congruent, then the lines are parallel. Okay, and underline the word parallel. So I'm writing on this side of the paper because I'm going to make the drawing over here. So this is the other way around. If you have two angles that are corresponding and that they are congruent, after you have two lines cut by a transversal, then it means that those two lines are parallel. All right, so let me show you how it goes. So this time we have two lines. We're just going to call them lines J and line K. So far, we don't know if they're parallel. But then a transversal cuts those two lines. Here comes the transversal, se les atraviesa, it goes and intersects them. And then we know that this angle and this angle, these two are corresponding. Remember? Corresponding angles, this one and this one. And they happen to be congruent. One arc, one arc. It means that they measure the same. I'm going to put it right here. This is angle 2, this is angle 6. So if we know that these two are congruent, okay, by putting one arc and one arc here, we're saying that they both measure the same. Okay, if instead of having one arc here, and if let's suppose I put two little arcs right here, then I'm going to use a pencil because I don't want you to actually draw it. If you see one arc and two arcs here, then those two angles are not congruent. So that's why I use the pencil, because I don't want you to write it. It was just an example. So if these two angles are congruent, then we can say that angle J is parallel to that line J is parallel to line K. Sorry about that, I'm ignoring my phone. Okay, remember these two symbols right here, this little symbol right here, you're representing parallel lines. Parallel lines. Because these two were congruent, then now you can conclude that J and K are parallel lines. Okay, that's postulate 16. All right, with this postulate, we're going to do the first example. So let's write it over here. Example number 1. And this is about apply the corresponding angles converse. Okay, while you write down that, let me put my phone in silence. There we go. All right, here's what this example says. Find the value of x that makes line M parallel to line N. So look at how the instructions are represented. Find the value of x that makes line M parallel to line N. Okay, so these are actually symbols representing parallel lines. All right, so here's what we have. This is the diagram. Here's line M, and here's line N. Here's the transversal. This is angle of 71 degrees. And this one over here is 2x plus 3 degrees. Okay? So what is going to make these two lines parallel? The only way that these two can be parallel if this one and this one, they're congruent, because they're corresponding. They have the same position. Okay? They're corresponding. So if these two are congruent, we can prove that by writing 71 equals 2x plus 3. By making this equation, we can solve for x, and that will be the proof that if x equals, let's get the value. In order for us to solve for x, what do we need to do? Subtract 3, subtract 3. 71 minus 3 is going to give us 82. No, I'm sorry. 80. Válgame. 60. 69, 69, 69. Sorry, 68. Oh my God, the math teacher. She's not able to subtract. Okay, 71 minus 3 is going to give us 68. So 68 equals 2x. So in order for us to solve for x, what do? we subtract, we divide 2, we divide 2. These two cross out, and the x equals, what is 68 divided by 2? Is going to give us 34. So if the x here is 34, this will make the equality true. This will make the equation true. So if the x is 34, then these two lines are parallel, okay? And that is our answer. And we say, let's write down the solution. The lines M and N are parallel when x equals 34. Okay? All right. That is the example for postulate 16. I'm going to box this postulate. Remember that you have to show me your highlighting. Okay. Next. Theorem 3.4. I'm going to be writing on this side of the paper and doing the diagrams over here. Theorem 3.4. Alternate interior angles converse. If two lines are cut by a transversal, so that the alternate interiors angles are congruent, underline the word congruent, then the lines are parallel. Okay, so you see, it's like doing the other theorems the other way around. With the other theorems, the ones that we did on lesson 3.2, we were saying if the lines are parallel, then the angles are congruent. This way is the other way around. If you find out that the angles are congruent, then the lines are parallel. So we have a system like this. Again, line J, line K, here's the transversal, alternate interior angles, I'm going to mark this one and this one, number 4, number 5. So if these two are congruent, then J is parallel to K. Okay. Next theorem. Theorem 3.5. This is the alternate exterior angles converse. And it says, if two lines are cut by a transversal, so the alternate exterior angles are congruent, okay, if the angles are congruent, then the lines are parallel. Okay, so we highlight the word parallel if the alternate interior angles are congruent. So again, we have a little line J, our little line K. This is the transversal, angle 1, angle 8. So our two alternate exterior angles are congruent. They measure the same. They're being represented by one arc, one arc. So we say that line J is parallel to line K. Okay? That's theorem 3.5. Remember, you can always pause or rewind the video for you to complete your notes. Theorem 3.6. Consecutive interior angles converse. If two lines are cut by a transversal, so the consecutive interior angles are supplementary, underline supplementary, then the lines are parallel. Okay. All right. And then let's draw our system. We have line J and line K. This is the transversal. And I'm going to put angle 3 and angle 5 here. I'm not going to put arcs. I'm going to say that angle 3 and angle 5 are supplementary and actually we need to complete this as a conditional statement, so it's going to say if angle 3 and angle 5 are supplementary, then line J is parallel to line K. So this is the synthesized theorem 3.6. Okay. All right, you're going to copy that, and we're going to do, let me see how we're doing on time. So I'm going to stop the video right here. We have to work on some examples, and then I think we can do a checkpoint because we know the theorems. So let's do one quick example. This will be another example. Can you prove the lines A and B are parallel? Okay. And they're saying over here that the measure of angle 1 plus the measure of angle 2 is 180 degrees. And this is the diagram. We have two lines, A and B. Here's the transversal. We have angle 1 and angle 2. So if the measure of angle 1 and angle 2, if we add those two, the measure of angle 1 plus the measure of angle 2 is equal to 180, we can say yes, the lines are parallel. Yes, the lines A and B are parallel. Because angle 1 and angle 2 are supplementary. Okay. All right, guys. So these are our notes. Monday, we're gonna do guided examples, and don't forget to turn in your notes. There's gonna be there is a bell ringer today, and I do want you to write an exit ticket. All right. So I'll see you Monday, and remember to remain on camera. Turn in your notes. Okay. Thank you. Bye.